This is Cadet Turkey Chacon, and I'm going to do the introduction for the Omaha Beach Capstone Team Sprint 1 review. Our team includes Cadets Stankiewicz, Harrison, Gamara, Lachey, myself, Beasley, and Navergrant. Our capacity for this sprint was 141 hours. One of our history cadets is only here for the first hour due to having class for the I2 hour, so we had to do some adjustments off that. And the actual hours we ended up putting in were 135.38, so we're getting close to the mark, and we hope to do a little bit better next sprint, just getting it more accurate. Our burn down, while still choppy, is a great improvement over our last sprint. I think it shows that the team is really getting used to the agile process. There are some cases of big jumps, but we hope to in the next sprint smooth this line out even more.
To reiterate our product vision, we are going to create a fully functioning 3D augmented reality representation of the Omaha Beach landings, paired with a physical map that enhances understanding of the historical content through an intuitive, interactive, and immersive experience that reaches a broad audience. Our Sprint 1 goal is to conduct further knowledge acquisition for historical content in Swift Code, refine product requirements, design the educational modules, and demonstrate the ability to manipulate 3D objects in ARKit through a mini project example. Alright, this is Ethan. One of the tasks on our sprint backlog was to create a user interface design for the functionality of the modules. So first we started out by generating a sketch. So Levi made a sketch of how he imagined the modules looking, and then he wanted to integrate pictures and 3D models as well. You click on and it'll open up a new tab. So this is just the initial sketch. From there, we moved on and actually developed a digital representation of how we wanted the modules to look. And then after that, we actually made a PowerPoint that shows the usability of the modules. So here's the home screen. To the right, there are write-ups. So this will be historical narrative that the user can read for educational purposes. And you can explore multiple subtopics. So if you click on subtopic 2, the historical content to the right will change, and you can read more content, subtopic 3, etc. At the top, the title of the module will be viewed, and then you can actually play a voice recording of a famous quote. To the right, we also have embedded photos, so if you click on this, it'll open up a new window where you can view the photo, and underneath will be a description or caption. And you can X out of that and go to the 3D model space, where we'll have a 3D model related to that module presented. So you open that, it'll open up a new window, and there'll be touch points. You can click on a touch point, and it'll bring up maybe a more detailed photo of that specific aspect of the 3D model with a little bit of historical content underneath. And just like the photo, you can X out of that back to the home screen, and we're right back at the beginning.
Cadet Lachey here, going to talk about the potential behind making custom shapes and adding it into our augmented reality. So as we develop further along into our project, we are going to be buying, most likely, 3D models to implement into our map to add the historical context of Omaha Beach. However, if we find ourselves unable to find a specific object that we want, or we find that it might be too expensive for our budget, we could actually look at making an object ourselves. As the augmented reality is in 3 dimensions, we can modify all 3 dimensions of any object we so choose to create in the X, Y, and Z dimensions. You can also modify the appearance of each object you would make, including the lighting, transparency, and texture. With the lighting, you can make a lot of use out of it by changing the lighting to best fit the setting, the time of day of Omaha Beach. So in the daytime, you could have the light show on whatever object you make pretty well, or maybe dim it a bit if you feel like it needs to be in some sort of shadow. With the transparency, you can just modify the solidity or transparency of the object. If you feel the object needs to be seen more than anything else surrounding it, you can just give it a lot more of a solid look. But if you feel that it's too dominating in whatever setting it's in, you can also make it more transparent so it blends in with a bit more of a natural feel. With the texture, you can modify that specific object to kind of get any kind of look you want. You can mess with the colors yourself individually. However, you can look online and find a JPEG or PNG file. You could actually use that and it will wrap around the object itself, as you can see in this picture right here. That, I feel, gives us a lot more options. We find ourselves unable to pick some specific object that we like to place on the beach, but it actually is somewhat easy to make utilizing ARKit with Swift. I'm going to show an example of modifying the light parameters and transparency of an object on the ARKit.
Hello, this is Cadet Gamara. Today I will be walking you through all my contributions to the Capstone project and Capstone group within the past 2 weeks. To begin, I have utilized the help of Pluralsight with the certifications from Colonel Harvey in order to complete a few tutorials and gain further knowledge on Swift to aid the group. I'm very grateful to Colonel Harvey for allowing us to secure one of the few license agreements so that we could have access free to the tutorials, and I've spent the majority of my time completing this task on Pluralsight, as noted in the Scrum Lord Google Doc. Up next, I have furthermore implemented, as you can see here, the Jared Davidson tutorials on how to make AR white dots appear, and personally customized this feature with the help of Cadet Harrison. In conjunction, I've done a lot of research on Stack Overflow, as seen here. This is the main. This is just an example of some of the code that we were able to pull from Stack Overflow and implement it in a personalized test case in which we edited the Swift code that was provided for the white dot tutorial in order to create ships that would appear. This is just one of the few cases where we've definitely demonstrated our enhanced knowledge on Swift and making it more usable and personalized to our project. I think this will help us moving forward in the future and allow us to have a more organized front. Furthermore, we've also highlighted some helpful links that we've come across in our research that everybody in the group can reference.
For this sprint, I focused on getting a hands-on understanding of Xcode, Swift, and the ARKit library by implementing an example program. To do this, I referenced a YouTube video created by Jared Davidson where he created a simple application that allows the user to tap the screen of their iOS device and make a white sphere appear in their AR environment. After implementing Jared's original code, Cadet Gamara and I researched ways to import 3D model files into the AR environment in place of the white spheres. You can see this implementation here. Our key takeaways from this small project were that Xcode has an ARKit template file already built in. This is helpful to us because previously we had tried to implement our project from scratch. Apple has detailed ARKit and Swift APIs on their developer website. We also learned how to load our own 3D model into the AR environment. In addition, we learned how to access locations where the user touched the screen. For the next sprint, we hope to find a way to get the code to recognize an image, such as a QR code, and then make a 3D model appear at that location.